So we went as far as question 4. So still 2019 exam paper. We are on question 4. So we did question 4A1. So we're looking at A2. Use binomial expansion to express 1 over 1 minus 2x as a series up to and including the term in x3. And state the range of values of x for which the expansion is valid. So this can be written as 1 minus 2x to the power negative 1. So we can now expand because it's already in the required form of the 1. So we have 1 plus negative 1 as our n, and then negative 2x plus negative 1 our n, negative 1 minus 1, negative 2x squared over 2 factorial, which is just 2, plus negative 1, negative 1 minus 1, negative 1 minus 2, over 3 factorial, which is 3 times 2, and then negative 2x to the power 3. We're supposed to go as far as x3, and that's where we are. So this becomes 1, negative, negative, we get plus 2x, and then negative 1, so we have plus negative 1, negative 2 over 2, negative 2x squared, that's the same as 4x squared, plus negative 1, and negative 2, negative 3, negative 8, and then x3 over 3 by 2. Negative 8, that is negative 2 to the power 3. This gives us 1 plus 2x, and then negative 1 by negative 2, we get 2. So this 2 and the 2 down cancels. So we remain with plus 4x squared. Then again here, we have negative 1, negative 2. They take away this 2. Negative 3, the 3 takes away that 3. Then this negative and that negative will have positive 8. So we have positive 8 x3. And so this is our expansion up to and including the term x3. And then from there, now, we state the range of values for which this is valid. The range of x values for which it is valid. Okay, so we get the inside and take it in the modulus. Only the negative 2x goes in the modulus. It must be less than 1. But the negative 2 comes out of the modulus as a positive 2, less than 1. And this entails that this is less than 1 over 2. If I want, I can write as negative half less than x less than half. I said if I want because it's optional there. Then we go to the third part. The third part, use part 2. Using part 2, find the approximate value of 1 over 0.98. Giving your answer correct to 5 decimal places. Now what you do is, this tells you To equate the denominator that you have in part 2 to 0.98. And so for x, so if you take one the other side, what do you have? You have negative 2x is equal to 0.98 minus 1. That means that negative 2x is equal to, that is 0.02, okay, negative. Then you divide by negative 2, divide by negative 2, you obtain x is equal to 0.01. So in the expansion that you have, okay, if you say 1 over 1 minus 2, 0.01, this is going to be 1 over, or you take it systematically. So on the left, you have written 1 over 1 minus 2 multiplied by 0.01, meaning that where there is x, we've taken 0.01. So we'll do the same even on the right hand side. Where there is x, we'll take 0.01. 0.013. That will be the case. And then if you want to convince yourself that it is indeed 1 over 0.98, you can subtract, because this will be 1 over 1 minus 0.02. Okay, and so you have 1 plus 0.02 plus 4, 0.1234. When you square, we just increase the decimal places. The same thing happens when you cube. You just increase the decimal places like this. And then this is, I said this is 0. What? So this is 0.02, okay, which gives us 1 over 0.98 is equal to, that is 1.02 plus 0.0004 plus 0.000008, okay, implying that what you have as 1 over 0.98 to how many significant figures? To 5 decimal places. So it will be 1.0204 because it's supposed to be 0.8 when we add all these. So you are saying approximately, which is approximately 1.02041 to 5 decimal places. So you round off the 8. So you just pick a 1 from 8. So this is how you use part 2 to approximate part 3. Any questions? Okay, so there's the request that we will do 3. So in 3, there's We don't have much work to do in 3 because we have already done everything in 1. The only thing that we have was to realize that when they say 1 over 0.98, they have affected the denominator for part 2. So we equate that denominator to the new denominator 0.98. From there, we solve for x, which you find in that form. Okay. After that, you now substitute wherever there is x, you take 0.01 because that's the value of x in the expansion. And you realize that as you substitute on the left, you're remaining with 1 over 0.98, and then you do the expansion. When you're squaring the decimals, you just take care of the decimal places. That's the only effect that the decimals have, especially when you are squaring a 0.01, 0.001, 0.001. So you just take care of the decimal places and keep adding until you get to the required solution. Just remember to check the number of decimal places, because if you don't express in the required number of decimal places, you lose 2 marks for not knowing how to express the decimal places, because it means that you don't know how to round off, or you don't understand what they mean by 5 decimal places. Okay, so we go to B. This is 4B. The polynomial Px is equal to 3x3 minus 2x squared plus Px minus q is divisible by x minus 1. When you hear divisible by x minus 1, immediately equate it to 0 and obtain the value of x. Before you forget, bring that value of x in P and equate it to 0. Because being divisible, it means that the P of that number, the x value that you got, will be 0. Okay? You leave it there and leaves a remainder of 10 when divided by x plus 1. Again, equate it to 0 immediately, obtain the value -1. Come back here and say P of -1 is going to be the remainder, which is 10. Okay, now I can start doing everything properly. What is P of 1? That will be 3, 1 to the power 3, minus 2, 1 to the power 2, plus P1 minus Q, which is equal to 0. Then the other one, so you call this equation 1, and okay, and the second one, -1. So you get 3, -1, 3, minus 2, -1 squared, plus P, -1 minus Q is equal to 10. This is equation 2. So that if you express that one, you would get 3 minus 2, 3 minus 2 plus P minus Q is 0. And the other one, remember, it's 3 or 1. And the other one, -3 minus 2 minus P minus Q is equal to 10. That's your 2. So from 1, we have P minus Q is equal to -1. That is 3 minus 2, there I get 1. The other side, it becomes -1. That is from 1. What about from 2? We have -3 minus 2, that's -5. So we are saying if we divide throughout by negative, the negative will go to 10. So just leave it like that. So say -P minus Q is equal to 10 plus 5. That is 15. This is 2. Okay. So there we have negative p minus q, which is equal to 10. And then negative 5 goes outside as a positive number, so we get 15. We can now solve as we can now solve simultaneously. So you know, if you add these, what we get is negative 2q is equal to 14. So divide by negative 2 by negative 2, you get that q is equal to negative 7. Then you go in 1 and substitute q for negative 7. It must be equal to negative 1. So you get p is equal to negative 1 minus 7. And this is equal to negative 8. Therefore, your p is negative 8 as your q is negative 7. So that is very correct. As you can see, so you have found the values of p and q. Okay. Any questions here? We're now moving to C. Okay. So that was B1. B2. So did you indicate that B1? Okay, B1. And then B2, solve x3 minus 3x squared plus 4 is equal to 0. So x3 minus 3x squared plus 4. What do we need? We need to look for a number that will satisfy that equation for us to use in order to factorize the left-hand side. Because that's a polynomial of degree 3. So if you try 1, obviously it won't make sense. So if you try negative 1, negative 1, 3, that plus 4, you get negative 1 minus 3 plus 4, and this is negative 4 plus 4, which is 0. So now we leave the 0 on the right and pick that to be factorized using negative 1. So by synthetic, we're picking 1, negative 3, 0 for x, and 4. And then we add a 0, we get a 1. We multiply negative 1 by the 1 down, we get negative 1. We add, we get negative 4. You multiply, you get positive 4. You add, you have 4. You multiply, you get negative 4. You add, you have 0. From there, you have now reduced it. It has now become x plus 1, because that is minus. So the factor could have been x plus 1 for us to equate and then get x as negative 1. Multiplied by x squared minus 4x plus 4 is equal to 0. So this means that x plus 1 is 0, or x squared minus 4x plus 4 is 0. So two numbers, when you add, you get negative 4. If you multiply, you get positive 4. We now have negative 2x and negative 2x plus 4. Negative 2, you get 4, and the sum gives you the same. You factor out x, you factor out minus 2, so you get x minus 2 x minus 2 is equal to 0. So what you're saying is x is equal to negative 1, x is equal to positive 2. These are the only solutions that you get in there. Because these two numbers here, x minus 2, x minus 2, do repeat. So you have nothing to worry about there. And that's how you get the solution to this equation. Any questions? So if everything is clear, you can see that C is induction, and induction is not part of our coverage this year. So we go to question 5. Question 5, express as a single, that is A. Express as a single logarithm 2 log 4 2x plus 3 minus log 4x minus log 4 2x minus 1. Now, if you watch the tutorial videos that I send, it will be easy for us to move fast in this revision exercise. Because we have such examples in the tutorial sheet. And so, since the bases are the same, the first thing we do is to take back the power 2 where it belongs. Remember, it belongs here. So bring it there. And then, so power 2 minus log 4x minus log 4 2x minus 1. The next thing is, actually these are equal, we're using the equal signs here. These are equal. So the next thing now is where we have, we can do it in parts. We leave this one and we have minus log. There's a minus there also. So what do? If we factor out the minus, that will be a product there because there will be a plus there. It will be log 4x plus log 4 2x minus 1. So you do this to avoid any possible mistake. So you have that 2x plus 3 squared minus log 4. When they are adding, you multiply the inside like that. And when they are subtracting, what do you do with the same base? You divide. So now you have this squared over x 2x minus 1. So you have expressed this as a single logarithm as required. So it's a simple task question once you understand the logic there. Okay, then question 2 now. A2 says, hence, when you see hence, what they mean is from where you have ended, solve the next question. So they're saying, hence, solve the equation 2 log 4 at 2x plus 3 is equal to 1 plus log 4 x plus log 4 2x minus 1. So what do you realize here? You realize that you can bring these to the other side, and what you're going to have is this 2x plus 3 minus log 4x minus log 4 2x minus 1 is equal to 1. You leave the 1 alone. But you've seen that this, from the equation above, gave us this 2x plus 3 squared over x 2x minus 1. Now we're saying this is equal to 1. What does it imply? It implies that 4 to the power 1 is equal to, you now take it to exponential, is equal to this over x 2x minus 1. And that is just 4 on the left. So I bring it here. So it becomes 4. So then we can cross multiply now, so that we have 4. As I'm cross multiplying, I'm expanding also there. 2x squared minus x is equal to, I'll put this in this form so that it doesn't seem to be a shortcut, plus 3. This implies that you have 8x squared minus 4x is equal to 4x squared plus 6x plus 6x plus 9. When you expand on the right, so we bring the 4x squared the other side, we remain with 4x squared. That is negative, that is positive 12 here, positive 12x. We bring it on the left, we'll have minus 16x, and then the negative 9 is equal to 0, which is a normal quadratic equation now. Okay? You're looking for x. So what will be your x? You now have 4 times negative 9, that's negative 36. Two numbers. You add, you'll get negative 16. You multiply, you'll get negative 36. What numbers are those? That will be 4x squared plus 2x minus 18x minus 9 is 0. So you should be very quick to find them, those two numbers there. So you factor out 2x and remain with 2x plus 1. Factor out negative 9 and remain with 2x plus 1 is 0. And so you have 2x plus 1. You also have 2x minus 9 is 0, implying that 2x plus 1 is 0, or 2x minus 9 is 0. So x is negative half, or x is 9 over 2. Are you able to take negative half there and have things defined? Obviously, there will be an issue in the first equation. This is negative half. You bring it here. It becomes undefined. So your solution becomes x is equal to 9 over 2. This one does not have any issue with anything. So that's how we get the solution there. Is that okay? Or we have questions? So just emphasize that, make sure that you watch those videos as they come, so that when you revise in the past paper, if you had any question on that concept, for example, when you're watching logarithms, you had a question. This is not the time to ask those questions, because this is a logarithm that you're doing. When we move to trig, if you had a question on trig, when you do a trig question, That's not the time to ask if you have a question on graphs and you're doing tree graphs. Okay, so let's um log out and log back. We're almost. So if you start a question here, will be cut off before I finish it. So let's log out and log back quickly.